I'm Anil Kumar, sharing with you an important question on approximating volume this time. The question here is, water leaked from a tank at the rate R of t liters per hour. The rate decreased as the time passed, and the value of the rate is given in the table below. Find lower and upper estimate for the total amount of water leaked out. So we are now talking about not the area and distance. It's more about the amount, which is volume, right? So we're talking about volume and rate. Okay, so that's what we're talking about in this particular video. Now let me sketch a rough graph and provide you the strategy which is going to help us to solve this particular question, right? So it's a very rough sketch here. What we have on this is we have time in hours, and then on this side we have rate in liters per hour. Okay, now as you can see, we're talking about interval between 0 to 10. The measurements are being done after every 2 hours. So at 0 it is kind of 9. So let me just say this is 9 for us. Okay, and then just drops down, and the minimum value is 4.5, so say half of this. Okay, so that'd be too tight. So I'll kind of make it, let me break the scale here and say this is 4.5 for us. Is that okay? Okay, now that's 4.5, and 4.5 will be at 10. So okay, so what I'm also going to do here is so for 2, let me just draw a few lines here. So that's it. This is after 2 hours, this is 4 hours, 6 hours, 8 hours, and then 10 hours, correct? So we'll just draw a graph and end it here at, and so it is kind of going like this. Let's say this is the point. Let us say that is the graph for us. Okay, now for this particular graph, we need to find lower and the upper estimate for the total amount of water leaked. So total amount of water leaked is the area of this curve, which is under this curve, correct? Now this area for a curved surface, we could approximate using rectangles. So that's the whole idea, right? So that is how we could do. Now if I make rectangles kind of like this, do you see this? A rectangle like this, a rectangle like this, rectangle like this. So these are my rectangles, and in these rectangles, if I take the right side, I'll get a lower value of this particular area, which actually represents the amount of water leaked, correct? The volume, correct? So that's how it is. So this is 2, 4, 6, 8, and 10. So what we will do here is to find the lower estimate. So there are 2 estimates which we need to find. So let me say lower estimate is L, and since we are using how many rectangles? 1, 2, 3, 4, and 5 rectangles in this particular case, right? So we have so this interval has been divided into 2 of each, right? So each width of this rectangle, let me call this as delta x. So in this case, delta x is equals to 2, correct? And we have a total number of rectangles as 5. Okay, so I'll say that the lower bound will be the one in which we are going to consider the right side. Actually, I should write lower estimate first, right? Estimate. So the lower estimate will be when we consider the rectangle's right side. So I'll use R5, right? That is going to be lower in this case. So the area of each rectangle is the value of the height is represented by this value, correct? So for the first rectangle, which has a width of 2, the height is, if I take the height from the right side of the curve, will be 8.1. Do you agree with me, right? So that is what it is. So we could write this area of the first rectangle as 2 times, let me write in brackets, 8.1, correct? Plus again the next rectangle, this is 2 and the height is 7.0, right? So we can write this as 2 times 7.0. So we're basically taking the right side to find the area of each rectangle, and since it is dropping, the rate is dropping, as you can see in the graph, the right side of the rectangle gives us the lower value of the amount of water leaked, correct? So let me just add them up. So we have 2 times 5.9 plus 2 times 5.1 plus 2 times 4.5, correct? Or you could say 2 is common and we can add all these 5. So that's faster way of doing it, and normally you should do like that only in your test papers, much faster, and I hope the concept is clear, right? So let me take the calculator now to calculate this value. Okay, so it is 2 times within brackets 8.1 plus 7, let's say plus 5.9 plus 5.1 plus 4.5, bracket close, equals to, in decimals, 61.2. So we get 61.2 liters. So that is from the right side, correct? Now let us do the upper estimate. So the upper estimate will be when we take the left side of these rectangles, right? Okay, so in this case we'll consider left side. Okay, so basically now what I'm saying is the rectangle will be kind of, let me use another ink, this one, this rectangle is over the left side. Do you see that? So obviously the area under the curve now has increased. This is because the graph is decreasing. This is this one, right? So that becomes the higher value, correct? So now we are calculating this value. So that becomes the area. Okay, so the higher value. Okay, so let's calculate this higher value, and just as we did previously, since we are using the left side, I'm writing L, we are using 5 rectangles to estimate, so L5, that's our nomenclature. Width of each rectangle is again 2, and the values of left 5 will be these 5. Do you see that? So we'll just put them in bracket and add them up. So it's 9.0 plus 8.1 plus 7.0 plus 5.9 plus 5.1, and then we can use calculator. Correct. So it is 2 within brackets 9 plus 8.1 plus 7 plus 5.9 plus 5.1 equals to within 70.2, right? So we get 70.2 liters. So that becomes the upper estimate for the total amount of water leaked, right? So our answer is the lower estimate is 61.2 liters and the upper one is 70.2 liters. So the amount of water is definitely between these two limiting volumes, right? So that is how we could do it. So this example also shows you that if the graph is, or if the rate is decreasing, then it is the left side of the rectangle which gives you higher values than the right. Right? So I hope that helps. Thank you and all the best.